Yeah, we're going back to oil and gas again. Feels like we're going back and forward today. So back to oil and gas, very much on upstream and actually really looking at subsurface more than anything, although it's kind of sort of a common problem. Dr. Emma did, I think, a really good job this morning of showing there's so much potential basically for how the digitalization agenda, the use of data science can really make a difference in the oil and gas business, and definitely in subsurface. The point I want to make here in this presentation is that I think that what's holding us back is the way we've been managing data up until now in subsurface. Carl mentioned earlier that there's a statistic for, I guess, almost all data science analytics projects, whatever industry they're in, that the data wrangling part can take up to 75–80% of the time. It's even worse in subsurface, I think, partly because of the complexity of the data, and partly because of the state that the data's in, because of the way we've managed it. So that's the main message that I'm going to try and cover now. So a quick recap on why we want to do the data-driven thing anyway, although it is a very quick recap because it has been done very well already today. What I mean by a modern data platform, and then in case you get all overwhelmed about what a big job this seems to be, we'll talk about what's an agile approach to actually populating this platform and getting to a point where the data is ready for analytics. So let me just do a quick build on this because we don't need to spend any real time on this. I think Dr. Ahmad had this exact same slide because it's one of my favourite slides for showing all of the aspects of any of the Industry 4.0 digitalization aspects. The one part, the reason I like this one particularly is this ring in the center that says data and analytics has to become a core capability. So it's not something we outsource anymore, it's something we actually need to bring in-house as part of the company. And it's, the data science and the analytics is important, but the data management is very important as well. And so for those of you who don't really know who Teradata is, because we've only really been working in oil and gas for 7 years, I think, although Teradata is quite an old company. So Teradata was formed in a Californian garage, it's like one of those startups, back in the 70s, when we were working in the finance area. So the very first Teradata projects were actually being done with Caltech University and one of the major banks in the US. And it was all about how a traditional bank in their mainframe world with, their kind of, the transactional data they have, how they could get more predictive and how they could bring analytics and a data-driven approach to finance. So we started way back then. We've been through a phase of doing a similar thing in the retail industry when point of sale systems first came in, when detailed data was available on stock control, but also how people were buying things, when loyalty cards first came, and we could start to map customers. So every time an industry gets to this point where there's a disruption possibility because of the data available or because of the technology available, Teradata starts trying to do some work. And we've done similar things in telco with call detail records and what they can learn about customer satisfaction, churn in telco. We sponsor various industry or say academic pieces of work every so often as well about to try and prove that you can have a data-driven approach to proving that a data-driven approach actually makes a better, more successful company. So this is one of the books that came out of some work with Stanford and Wall Street Journal, where they could basically prove in the data that data-driven companies are more successful, higher productivity and higher profits on average than the equivalent companies that are not data-driven. So I'm assuming we're bought into this anyway because it's happening. And also in our industry is so technical anyway. And we do have masses of data. And we spend masses of money on sensors, on everything that we do, on taking surveys of everything we do. The problem is when we then try to use that data. So this statistic that could be, we use 5% of the data, or McKinsey say we use 1% of the data. It's not the data's not used at all. It may be used for an immediate real-time alert, but the data's not normally kept online in a way that you can analyse and make available for your data science projects afterwards. When I look at subsurface, we've been managing subsurface data specifically. We've been like building archives of data based on the type of data it is, right? So you'll go, I put all my well data in the well database, and then I'll put all my seismic data in the seismic database. I'll put all my operational data that came from like production ops, topside facilities in another database again. And there'll be more than one of each of these. And then every time it needs to be used, we've been manually moving the data from the corporate, the corporate store, the master store, and then taking it over to the application store. As well as that being, a bit dodgy in terms of QC, it's a bit fraught, with some errors creeping in there. It just doesn't scale. And if you add on now that we're trying to do the same thing again to support all these new data science projects, every single time somebody wants to do a new piece of analytics, we're going back to these sources and we're pulling out some original format files again. We're extracting from a historian, or we're going back to original DList files or whatever, and then pulling this data through. It's just never going to scale. So I think the reason this came about is, and we have a cyclical industry, right? We very much, in the same way that the price goes up and down, and we lay people off, we hire people and we lay people off. The other thing that happens is we insource and outsource capabilities over time. And it must be almost 2 decades now that we basically outsourced the data management function to software. Right? So we've been buying in applications that almost tell us how to manage the data. And if we get data that doesn't fit in those applications, we have to edit the data to force it into the applications. It's a really kind of backward way of working. And it would be great if there was only one app, right? Because the app is telling us how it wants to acquire the data. We've got to match that. It's going to decide how it stores it. And then which analytics we can do is dependent on which software we've bought. It'd be bad enough if there was just one. But we do that for every single data type, and then we do that for every single workflow. And then the data managers, we're just trying to put band-aids on stuff left, right, and center to try and make it work. Because it's not really an ideal setup. So when I'm talking about a modern data architecture, and maybe modern's that's a weird word to use for this, but I'm not saying a specific technology. It's not about whether it's in the cloud or whether it's on-premise or any of those choices. It's the approach we take to how we think about the data that's important. It's one of those diagrams Teradata uses all the time. We call it the reference information architecture. It's just the things you need to think about when you're bringing data through, regardless of whether it's data which comes from a real-time source, whether it's surveys, it could be your well log data, your seismic data. It could be business-generated data that's in SAP. It doesn't matter. You need to map that data to how you want to land it on the platform you want to work on, and how we can standardize it some way so that we can join things up. And that could be as simple as making sure we use the same well names, or we use the same names for the actual facility, the oil field. So it's standardizing some of that data. We need to identify what the keys are for the data so that when you want to join from one data set to the next, we've already worked out how you're going to do that. Deriving data for us, because there's so much measurement data, that might mean creating standard sets of data that mean the data scientists can get to work already without having to do calculations. So if we have units of measure for something, some of the data's in meters, some's in feet, because it came from an American company, we should make one standard copy as well, right? Don't throw away the original, but add on, here's the one that's already standardized so people can join data and not make a mess. And the same for our coordinate reference systems. So a lot of the data is going to be projected, so we're going to have X, Y data, but just so that it's easy for somebody to write an application later, let's also add something standard, like your WJS84 lat long. Just add that data there as part of the derived. And what that means is that we can bring the data through once, store it in a way where it's clear for the data science how they're going to work on it, and then we can make additional views to optimize apps, but it basically means regardless of the app, they can be pulling the same data. Because today, I'm certainly seeing almost all the oil companies I'm working with, I'm seeing people starting these data science projects, they almost all need the same data. They're taking it from the raw source. They're all doing almost the same work to standardize, to clean up the data. We're ending up with just more and more and more copies of data in a different platform. So they're building their new platform in the cloud and a data lake, but it's just a bunch of copies of the old data. So looking at it from back to this app point of view, if this is the way we used to work, so each app had everything inside its responsibility, we start moving some of these features back. So first thing you want to do is make sure that you're acquiring the data somewhere and doing the basic organization. Once you see that people are making the same calculations again and again, you can move that part too. So you can actually, the data platform will get more and more capabilities as the work is done by these individual data science projects. So the idea in the end is that the platform itself grows with the new features that have been engineered by data scientists, new knowledge comes back in the platform, and the new apps get simpler and simpler. So you can do more work, you can bring more innovation into the business very, very easily, because the individual apps don't take much work at all. This is like a 20-year-old slide, I think, but it's still really relevant for the oil and gas industry, because we didn't do this thing that a lot of the other industries have done before. So when I was mentioning we've worked with retail as they changed their model to really understand customer or really understand their product list and their supply chain, they went through a data architecture, stage, I guess, where they had to really think about what data is important to them, how they model it, how they approach it, how the data hangs together, how it gets updated, all of the aspects about the data. So we have this thing that we call the architecture cube, or the bias cube sometimes, because that's what it says across the top. It's like business information application system. So everything should come from a business need. We're doing it for a reason. The next thing we should look at is what data is needed, what information is needed to match that business question. Then, how are we going to build it? What's the app? And then, what IT does it need underneath? Now, because we've been in this build versus buy, we've been skipping over information. We've been saying, business, what's your question? Is there an app for that? Right? We're just jumping over that level. So there's a bunch of work that we haven't really been doing. I won't go through this in detail, because it's I could spend like a 2-hour training class on this. But you can see, so I would starting from the top level, conceptual, logical, solution, deployment down the side. So we think about what we're going to do, we plan it out, and then we get more detailed as we go down. At the top level, we need to understand what key concepts we actually have in the information level. So as an organization, we need to have a high-level model of the most important things that we're going to keep data about. So a well is going to be one. Maybe also a well board, whatever else. Field, the license, whichever aspects. You need to map them out in a way that everybody agrees the words. When we come down again, at the logical level, you're going to map more detail, what it is, what data you need. At the solution level, you're actually going to get down to how does that data relate, what are the keys, have I standardized it? And then finally, physically, you're going to land that data somewhere and make it ready for people. So, in the olden days when people did this, like if I really do go back to when the banks first did this in the 90s or whatever, they did have a habit of, in the same way that IT projects used to be done in this waterfall way, where somebody would plan it all up front, and then people would like lock themselves in a room for a year and do this detailed data model at the top. We don't do that stuff now. It's not the way we work for development, and it's not the way we're going to work in data management either. So we need to have a much more agile approach for tackling this problem. Because anybody who works in subsurface data knows this is quite a big problem. There's a lot of pieces of data that we need to look at a different way. So, first thing I say, well, think of the different actors that are involved. And because everybody uses this data lake, data swamp, data reservoir, blah, 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 when they're talking about data, I'm sticking with the water theme to try and explain who's responsible between the end-to-end chain of data coming in and getting it out to the end user. So the IT group, and I think we need to get a bit more familiar with our IT groups, because as subsurface data people, we tend not to talk to corporate IT unless it's different in your companies, and certainly most of the oil companies I know, there's an attitude in subsurface that corporate IT do the email. Maybe the SAP system, but we're not sure we're going to trust them with something like a well log because they don't know what it means. So we're going to have to find a new way to work together when we need their help, basically, for what I'm calling the plumbing and making sure that the water pressure is okay. We need to be able to describe our requirements to IT in a way that means that they can build the right plumbing for what we need to do. Our job in data management is going to be about making sure, I say water cleanliness, making sure that the quality of the water, the data, is what's going to be needed for the end user. And we're going to have a link. We're going to rely on IT to make sure that there's pipes to get it there and that it doesn't get damaged in the way. But we need to set up something that's going to get the right level of water quality, and we need to keep measuring it and checking it to make sure that it stays at the quality that's needed. And then the way I see the end user in this, in the world of analytics, is the combination of the business requester and data science. Because the analytics teams are the ones who need to have this data to serve the analytics, which is going to bring the business value. So yeah, we are going to have to play with IT and working, I think, hand in hand with data science is the pull mechanism. Because the other way I'd say this is this, basically. We can't do everything at once. We have to prioritize what data we're going to move through. So we should prioritize it based on business value, and that should be because somebody in the business, probably through some digital COE or through some management or possibly even a research department, they're going to identify projects that they believe are going to bring significant business value, which are worth doing. We're going to work with them to help identify the data they need for it, what quality it needs to be at, and then work with IT to bring that data through to the new data platform, standardized and ready for the data scientists to be able to pull the data from that to build these workflows. And as it says over on the right, we want to do this for the new workflows. Because if you take an old process that we do today without rethinking it and add on all this expensive technology, you're just making an expensive old process. We really want to use this opportunity to make sure that we're doing the right things in the right way going forward. This is one of those too many words slides, sorry. You might have heard the terms data engineering or data pipelines, and it sounds quite far away from the way we've traditionally worked with subsurface data, because most of our world has been like file import and then fix the dialog boxes. It's been very manual. And as I mentioned before, because that was controlled by the applications, it was very hard even to put corporate standards on these things, because basically the application dictated half of the standard. It was also very manual. There was a possibility for human error, which meant that it's quite a painstaking job, and it took, or it still does take, a lot of knowledge. I mean, the job of subsurface data management is crazy wide, because you need to know a bit of petrophysics, you're going to need to know a bit of seismic, you're going to understand geomatics, you need to know things about units of measure, you need to understand things about countries and culture and all sorts, as well as the applications themselves and how we do it. Ideally, we want to take that knowledge and use it for higher things, shall I say. And the things that are just repetitive, we'd like to work with data engineers to get as much as possible automated, coded up into a kind of more modern approach, which they would call data ingest pipelines. So data management absolutely need to define the data flow and how we want to take that data through. They're the people with the knowledge in the company. But a data engineer should be able to automate that process, which could be all about dealing with the binary files and splitting them out, parsing that data, but then doing master data checks, make sure if it's a well log, make sure we know what well it belongs to, make sure the data's correct. Understanding how it's going to be used later, but we should be able to put as many quality checks in there as we want, and then we can start doing data management by exception. So only if something doesn't match, and we know that a lot of the data, the headers are bad, something's going to be missing. But we only want to look at the ones where they're bad rather than looking at every single thing. And then these data pipelines can also track what's happened to the data all the way through and store some lineage, which will be useful later. when I've spoken about this in some other conferences, like in Norway, there's still this fear about some of the formats from the past. So the SegY, the SegD, the DList, the things that are binary. Because most oil companies didn't really have easy to use tools that allowed them to look at these files. They end up using Betrayal or the Landmark Suite or something to look at these files. These applications that cost like, I don't know, $100,000 a seat, and we're using them just to look at a file. But the world is really changing here. There's quite a lot of people doing work on this, either in universities or oil companies who are actually starting to share these parsers as well. So the list of open source parsers for this data is getting larger and larger. We just did one, so I'm doing a lot of work with Equinor, company formerly known as Statoil. And one of the things, they're very big on trying to help this movement. Who was asking before about data sets? Was it? So they've taken the move to, they've got one of the oil fields in the North Sea which has just stopped producing. They've just shut it down. So they've opened out the whole data set. They've just put it online for anybody to grab. So that's one way that they're trying to give back and make sure they can stimulate this kind of data science in the community. So it's the Volva data field. If anybody wants it, I'll share the link. And then they're also doing the same with parsers. So we've just worked with them to write a good Python parser for DList. So nobody needs to be scared of DList anymore. It's like 2 lines of code now to have any of your data engineers open that file up and do something automated with it. And the way we've worked, because of all those things I've said before, meant that all the standardization we did to data, we did inside third-party applications. So the real change, I mean, maybe I'm kind of overemphasizing this, but the real change is to fix the data first. So even if the data needs to go to Betrayal because it needs to be used by some interpreters at that point, fix it first, because then it can go not just to Betrayal, but also to the data science projects, and also to some in-house developed apps that will do something else. So fixing the data should be the earlier step. And fixing the data to me means checking your master data so you know it's the right well. Checking the reference data, like could be curve mnemonics, could be the units of measure. Doing what we can to make the job easier for the data scientists later, so standardizing the units of measure, the CRS, those kind of things. Tracking all the metadata about how it came in, where it came from. So, because you don't know what questions people are going to ask afterwards. This data's gone through very traditional workflows up until now, but sometimes the data science questions that are thrown at us are things like, I don't know, so say out of the different drilling contractors we've used for the last 15 years, which ones are worse at filling in the header information? So you need to know, when your data came, who you got it from, what process it's been through, which was the raw version, did you have to edit it? You need to know all those things in order to answer some of these questions. And automate data quality checks when we're loading, but measure data quality consistently and visibly. I think it's really important that we can show what data is ready for analytics to the organisation. In some ways it'll spur some ideas about what they can do, but it'll also show the progress we're making as we're taking through all this whole data. Yeah, and then another thing, basically, if we want to support these new consumers, we need to open up to the idea that we do have a different kind of consumer now for our data in terms of the analytics. So think about the information architecture, think about it separate from today's apps. Do you know that our data lives for decades and decades, and these apps don't normally live for, maybe 1 decade, but they're not going to live as long as the data. So data first. Standardize where you can, and make it the goal is to deliver data that's ready for use in analytics.